15B yesterday, we did it wrong. Because I just assumed it would be the same as A, but it said 4 years and 3 months ago instead of 4 months and 3 years from now.
Would you put a negative in front of the, like that?
Yes. So the time, our time should have been a negative 4.25 instead of a positive 4.25. That'll move us back in the past. And 16 is the same way, 20 months ago. How many years is 20 months?
3, no, a year and 2/3.
1 year, 8 months, yes. 8 months is 8/12, which reduces to 1 2/3. You could plug the exponent in like that, or you could do 3 times 1 plus 2 is 5/3. And it's a go, so you'd have to make it negative. That's not the answer, that's what you put. So for 15B, the original amount was $150. The camera's price is increasing at 8% per year. So did you guys notice on 16 the price is decreasing? The computer depreciates at the rate of 25%. So the rate on 16 is negative, but on 15 it's positive. You guys remember that little formula? It's 1A times 1 plus R to the T. So the original amount, this would be 1 plus 8%. And so on the B, we should have plugged in negative 4.25 instead of 4.25 because we have to go time backwards in time. And it says they got, looks like they're running it to like the $1 place, US dollar. 15. Okay, now back to where we were, 23. We could have used this yesterday.
I was thinking.
Some fresh air.
Do you divide the top thingies by the bottom?
Yeah, so this is a distributive problem. But instead of like multiplying both of these terms by, whatever, we're dividing both terms by this. So distribute. So 2 divided by 2 is 1. So it kind of goes away. N to the 1/3 divided by n to the negative 2/3. What do we do with exponents when we divide? Subtract. So it's 1/3 minus negative 2/3.
So it's 1.
That'd be 1 plus 2.
1.
It's 3/3, which is 1. So it's 1 n to the 1. Or, in other words, it's just n. Minus 4 divided by 2. And then negative 2/3 minus negative 2/3. 0. N to the 0 is 1, and 1 times 2 is 2, so it just disappears. So all we're left with is n minus 2. There's a party going on out here.
Wait, so how do you get minus
No,
2?
that was last week. We do it every week.
divided.
4 divided by 2.
Yeah, that's right. Yeah. Yeah.
Never seen you do that, Lee.
What'd you do?
You like did like a
There's
tray.
a party going on.
It's not normal for Lee. Trey, you good?
Watching people walk out. They go on their prayer walk. Oh yeah, you don't get prayer walks anymore, do you? We get Mr. Frederick walks.
We get Totino, yeah.
Isn't just coined a new term, yappage.
Totino, yeah. Totino's
What's his new
It's the noun form of
Yeah.
Alright, any bright ideas for this one?
First you distribute the multiplying. And then
Okay, you could distribute first and then distribute the division.
Oh wait.
You could also, like, just divide these two. Because, and then distribute whatever's left over, because, when you distribute whatever's left over, that's like you're distributing the multiply and the divide.
Division distributive postulate.
Sure.
Yes.
Okay, so 2 divided by 2, that goes away. What's into the 1/3 divided by into the negative 1/3? So it would be 1/3 minus negative 1/3. Yes, it would be. Welcome. Thank you for joining us. Blessed by your presence.
What do you have to say?
Nothing. 1/3 minus negative 1/3 is 2/3, yes.
Great.
So now we can distribute that. Okay. So 3 into the, what's 2/3 plus 1/3?
1.
And 2/3 plus 4/3?
5/3.
No, try again.
6/3.
6/3, which is,
Me
6/3 is
2.
12.
2. That would be it. Alright. What should we do first? You know what? Probably the easiest way is to change these into rational exponents. So the top would be 4a to the what power? You guys remember this from yesterday? 2/3. And the bottom is 4a to the what power? Right? It's like the first power because there's no exponent over 6. Well, that's kind of what you missed yesterday, let's say, Lydia, the exponent thing. So anyway, now that I have them both in rational exponents, and they're the same thing, I can, how do I put these together? If you are dividing the same base, what do you do with the exponents? Subtract. So 2/3 minus 1/6.
So it's 3/6 or 1/2.
If we multiply this by 2, it's 4/6 minus 1/6, which is 3/6. which is 1/2. So it's 4a to the 1/2, or maybe they put it back in radical form. The 1/2 power would just be the square root. Where are we at?
27.
Totally lost. I guess they didn't really. Yeah, okay. They changed a little bit. Well, what's the square root of 4?
2.
2. So here's what they did. They just put 2 square root of a. Four has a square root, a doesn't. No. All right. So the trick on these is you can solve these equations. We did a few of these last year. If the base were the same. So how could I turn an 8 into a 2? 8 is 2 to the what power? That's what I'm trying to say. Right. So we can replace the 8 with the 2 to the third. Okay. And then what's 2 to the third to the x? You just multiply those together. 3 times x, that's just 2 to the 3x equals 2 to the 6th. Alright, now that their bases are the same, to make these two things equal, their exponents have to be the same, right? So we need 3x to equal 6, therefore x is 2. We're doing 8 again on number 31. Okay, so 8 and 2 can both be turned into powers of 2. 8 is 2 to the third again. There's an x minus 1 out there. What's this going to turn into right here?
3x minus 3.
Right. 3 times x minus 1, it's got to multiply it all, so it's 3x minus 3. So their bases are the same, so the exponents need to be the same. 3x minus 3 needs to equal x plus 2.
It's x plus 1.
Where? Right here?
No, other side. Thank you. So that means it's going to be 2.
Another 8. My word. So on 30, what could you do?
Oh. You can make it 9 squared.
You can turn 81 into 9 squared, yes. So then 4x would have to equal 2. They love the 8 one. Okay. So 2, 4, and 8, all the bases on this problem. 8, 2, and 4 could all be turned into a base of 2. So once again, 8 turns into 2 cubed. So that'll be 2 to the 3x. 4 turns into what? 2 squared. 2 to the 9th will be 2 to the what? 18th. How do I combine these two? Add the exponents.
Yeah, why is it at 4?
Hmm?
Why is it at 4?
Why isn't it 4?
4 to 2 times 2.
Oh no. So the 4 is inside here. There's like 25 2's multiplied together. You don't actually multiply the 2's. So x times x is x squared, not like 2x squared. The 4 is inside. There's a ton of 2's in here. Okay, you don't actually multiply these two things together. The multiplying of the 2's is in the adding of the exponents. Okay. That's not nice. Here.
Thank you.
Like 2 to the 1 times 2 to the 1 is 2 to the 2, right? Which is 4. Okay, you wouldn't say it's 4 to the 2. Does that make
It's just
sense?
like you don't do the extra stuff like that.
Yeah, like there's 4 inside of this, but there's a lot more than 4 in there. Anyways, 3x equals 25. That was a good question. A lot of people get that wrong. So, divide by 3. Oh, that's my place. 8x to the negative 30. All right. I'm not sure what the easiest way. There's a couple ways we could do it. Um, 64 can be written as a power of 8, right? 8 squared. If I divide the 8, I don't know, I feel like there's an easier way, but I don't know what it is yet. What will this be over here? 8 to the 5th. 2 minus negative 3. Okay, what's x to the negative 3rd mean? It'd be like 1 over x to the 3rd. And this is like 8 to the 5th, you could say over 1. Okay, one way we could do it, well, you guys think there's 2 ways we could do it. Does anybody have any ideas on this one? Like if x cubed's on the bottom here. You could cross multiply, yes. One way you could do it is cross multiply or multiply both sides by x cubed to get rid of the x cubed on the bottom. The way I was thinking is if 2 things are equal, then their reciprocals should be equal. That means if you flip them upside down, they should still be equal. do I get rid of a cube?
Cube
Cube
root.
root. Okay, well, that's gonna simplify. If I wrote it in exponential form, it would be 8 to the negative 5/3, because it's on the bottom. But that actually simplifies, because what's the cube root of 8? 2. And what's 2 to the 5th? You guys might not know that one. 4, 8, 16, 32. It's 32, but since it's a negative x, you can plug it in the calculator. You can plug that in the calculator too. This is 1 over 32. It's a tricksy one. Trixie. Is there an easier way? That's what I'm wondering. Did I not think of the easiest way to do it? Maybe. What if? Okay. Let's get 35B. 9, 8x. Nope. 8x negative 30. Wait, how's this different than the last one?
No,
Okay, so what's the no parentheses change?
It only goes to the x.
Yeah, the negative third is only on the x. So what would you guys think maybe do first? Let's get rid of that 8. So x to the negative third equals 8. Okay.
2.
Again, if you do the reciprocal trick, like this is like 1 over x cubed. So if we flipped it, it would turn into x cubed. But this would turn, if we flip this, it would turn into 1/8. It's kind of like I'm taking both sides to the negative 1 power. Which just means it's kind of like I'm flipping both sides. But that becomes a positive 3, but that one has to flip. How do I get rid of the cube? What is the cube root of 1/8? What's the cube root of 1? 1. Cube root of 8?
2.
2.
It's okay.
1/2 times 1/2 times 1/2 is 1/8. Plus x to the negative 30. Okay. So I'm just going to start off by flipping. Since all left sides to the negative third, I'm going to flip both sides. Or in other words, I'm going to make the left side a positive exponent. That's what I mean by flipping it. But the right side is going to go to 1/64. This is probably how they wanted you to do it. I think this is the easiest way. And then how do I get rid of the cube? Cube root. You guys know what the cube root of 64 is?
1/8.
No, that's the square root. There, 64 does have a cube root. Yeah, it's 4. So this will become 1/4. And Number 37. House was bought for $50,000 in 1980. Was sold for $150,000 in 1990. The nearest percent. What was the annual rate of appreciation in the value of the house?
Well,
All right. So the house started out as 50,000, and so
1 plus R or?
yeah, 1 plus R, that thing. It's gonna go up by a certain percentage every year. What do I put for the years here? 10, because we're talking about from 1980 to 1990, so it's 10 years. And we want the new price of the house after 10 years to be 150,000. All right, math geniuses. How do we get to that R? You gotta like shovel it out.
Did you divide the 50,000?
Yes, 50,000 is multiplied, so I can get rid of it by dividing. Gone, gone. Okay, still trying to get to that R.
You do the 10th root?
Yeah. It's kind of trapped by this 10th power. How do I get rid of a 10th power? A 10th root. Whoa. We're almost there.
Subtract 1.
Okay. Now R stands for like a rate, a percentage rate, like a rate of appreciation, like the price going up. So we need this answer in percentage form. So in other words, you gotta plug your calculator. We'll round to the nearest percent.
I don't know how to use a calculator.
You've used a root besides the square root before.
Yeah, I used the cube root, but not the 10th root. Oh wait, just saw the button.
Forgot to subtract 1.
0.1161.
Okay. So what's this as a percentage?
12%.
About 12%. Yeah, move the decimal twice. Rounds up to, let's say it's about 12%. Well, Leo, did you recognize the formula we used here?
Yeah, I recognized the formula.
Okay.
Then I got lost.
Well, okay. To solve for R, we had to get rid of this, this, and that.
Get it by itself.
Yeah. So to get rid of the times 50,000, we divided. To get rid of the 10th root, 10th power, we took the 10th root. And to get rid of the plus 1, we subtracted 1.
That makes more sense. It did.
In summation.
Is 38 the exact